The following is the video solution from JSDT Solutions. Question 8, 8.1 says, AB lies on circle with center O. Okay, so that's this circle over here. Okay, this smaller circle. And is produced to, so AB is produced to C, okay, which lies on the circle with center P, the larger circle. Similarly, FE is produced to D. Okay. BE is parallel to CD. And they want us to prove that ACDF is a cyclic quadrilateral. So ACDF. Let's highlight that. Okay. Now, with this diagram, it looks simple. And there's an advantage and disadvantage to when it looks simple. When it looks simple, there's not much to distract you. But also when it looks simple, it looks like it doesn't have much information. So really just think carefully about this. Straight away, I see that in order to prove that this is a cyclic quad, remember that there are three ways, right? There are three theorems that you can use to prove that a shape is a cyclic quad. Number one, if the exterior angle of this quad is equal to the opposite interior angle, this is a cyclic quad. Number two, if the opposite angles in this quad add up to 180 degrees, then this is a cyclic quad. And then the third way, if the angles in the same segment are equal, it's a cyclic quad. Now, looking at this and looking at this diagram, you can see that we don't have lines going across. We don't even have an exterior angle in this shape. So I'm going to eliminate these two methods, and I'm actually going to focus on this method, which is rare. I barely ever, with all these past exam papers I've seen, I've barely ever had to use this method. So this is a new one, and let's just see how we can do this. But I'm sure that they have done this before though. But then again, it could also be new. Okay, let's see. How can we actually do this? Remember guys, never try to start finding random things and then just hope that you get to the answer. Okay, because then that is really guessing. You could go wrong, or you could just not find anything. Sometimes it is helpful though, so that you can at least score marks if you did point out certain things that would be useful. So yes, in the case of an exam, you can do that. That would be helpful. But when practicing, don't find random things. You end up just confusing yourself. You need to create a strategy to get to the answer. So we know that we can use this method, right? Proving that the opposite angles add up to 180 degrees. So let's see how we can do this here. Okay, so let's plan this out and just think about which angles we're working with. So we know we need to take two opposite angles, but which ones? Now, I was thinking about going with A just because it's A, first letter. I just thought that maybe they just made a hint, and sometimes they do that, okay? They will just make the angle that you need to find A, or really it will go in alphabetical order. But we're going to have to think about it. So my first guess, let me just try these two first. Let's go with angles that are between these parallel lines. If we are focusing on the opposite angles in the cyclic quad adding up to 180 degrees, just because of the way the shape looks, then we can focus on angle A plus angle D adding up to 180 degrees. So that's what we're required to prove. Okay, so I'm going to put that down. What we are required to prove, RTP, so required to prove, is we're required to show that angle A plus angle D adds up to 180 degrees. And if we can show them that, then it means that the shape is a cyclic quad because the opposite angles add up to 180 degrees. Okay, so how can we do this? We're going to have to move from one point to another point. So I'm still leaving angle D selected, but just in a less vibrant color so we can focus on angle A. When we are by angle A, where can we move to? From angle A, just because of how simple this diagram is, the other place that we can move to is here. Do you see that in this cyclic quad, in the smaller circle, right? A, B, E, and F, we have a quad there. And this quad has an exterior angle, E2. So angle E2 is equal to angle A. Okay, so we've just moved. We have moved from angle A, and we are now at angle E2. And then from this point, how can we eventually get to here? Okay, so you see how, and now we can use these parallel lines, okay, because we need to form that 180 degrees. Do you see how these lie between parallel lines, and so they form co-interior angles? Okay, so this is co-interior angles, and co-interior angles add up to 180 degrees, and there we go. And so that's how we would do that. So we'll start at angle A, and we can say angle A is equal to angle E2. And the reason for this is because that is the exterior angle of a cyclic quad. It's equal to the opposite interior angle. Okay, so that's done. And now we've moved to angle E2. And from angle E2, you see that because it lies between parallel lines, the co-interior angles add up to 180 degrees. So angle E2 plus angle D that we have there is equal to 180 degrees. And this is because of co-interior angles, okay, on parallel lines. Okay, so you can just specify the lines that are parallel. BE is parallel to CD. So BE parallel to CD. And now this is everything we need. You see, because angle A is equal to angle E2 and these add up to 180 degrees, remember angle A is equal to angle E2. So in place of angle E2, we can just replace that with angle A. So that means angle A plus angle D add up to 180 degrees. Okay, you can easily see this with this information. We found that these two are equal. We found that these two add up to 180 degrees. So in place of E2, because these are equal, just replace it with A. That means that angle A plus angle D is equal to 180 degrees. And there we go. Okay, we have proven what we were required to prove. So that will prove that ACDF is a cyclic quadrilateral. Okay, because we have the opposite angles in a cyclic quad add up to 180 degrees. And there we go. We can just tell them that opposite angles in the cyclic quad, they add up to 180 degrees. Or we can just call it the converse of the opposite angles in a cyclic quad. Okay, so just call it the converse theorem. So converse of opposite angles in a cyclic quad. And that is how we prove that. Moving on to the next question. Question 8.2 says, in the diagram below, AB is the diameter of a circle with P as the center. Okay, and then EP is perpendicular to AB. So this is 90 degrees and this is 90 degrees. And then they tell us that prove that triangle BPE is similar to BDA. Let's highlight those triangles. BPE is this triangle over here. And then BDA is BDA. And I'll highlight that. Okay, so you see that we have one angle down. Okay, angle B1 is a shared angle in both triangles. So that's down. All we have to do is find one more angle in both triangles that are equal. And then we're done. Okay, so 90 degrees is a very good one to go for. And the reason why is because if it's 90 degrees, it's going to be clear to see that, yeah, that angle is 90 degrees. Okay, so straight away, do you see that AB is the diameter? Therefore, the diameter supports a 90-degree angle at the circumference, angle in a semicircle. And that would be it. Okay, so let's just go ahead and write it down. We'll say in triangle BPE, okay, because remember, if you have two triangles and two angles in both triangles are already equal, then by default, the third one is equal. Okay, so I was really only focusing on finding two angles equal, and then I knew I'm done after that. Then that's fine. Okay, so we have angle B1 being common. So angle B1 is equal to angle B1, and this is a shared angle. You can say shared angle or common angle. And then what else is equal? We have these two. So angle P2 is already 90 degrees because they told us those two lines were perpendicular. And we can see that angle D is also 90 degrees. So let's start by telling them that angle P2 was equal to 90 degrees because this was given, okay? We were initially given that EP is perpendicular to AB. So EP was perpendicular to AB. And then we can also say that we can see angle D is equal to 90 degrees as well. Angle D is equal to 90 degrees, and that is because of angle in a semicircle. Okay, and so this is one angle that is equal. We can finally conclude that angle P2 is equal to angle D. So these are two angles we have, this angle and this angle. And then the third angle in each triangle will be equal by default. So this angle, angle A1 plus A2, which we can just call angle, we can call it angle A because it's really just on its own like that. So angle A is equal to the angle here, the third angle here, which is angle E3. Okay, so there we go. We can say angle E3 equals angle A because it's the third angle in this triangle, or you can say the sum of angles in a triangle. Okay, so now that we have these three equal, we can finally just conclude that these two triangles are similar. So finally, triangle BPE is similar to triangle BDA because we have three sets of equal angles. And that is our answer. Moving on to the next question. Question 8.2.2 says, hence prove that BE is equal to PE squared multiplied by BA times BD over BP. Okay, so with these questions, once they ask you to prove that, two triangles are similar, and then they ask you a question like this, it usually has to do with the two triangles that are similar. So I'm going to take this and I'm going to just find the dimensions that they used quickly. Okay, so looking at this, you see how we have PE. Okay, let's start with BE because BE is over here. BE came from the first letter and the second letter. So that side BE. And so BE would go over BA. Okay, we have to take it over BA. So first and second in the second triangle as well. So BA. BP, and then I'll just compare it with what we have here. And we have PE. Okay, so where's PE? We have PE, and then I have to take PE with DA. So PE over DA. Okay, so that's usually the case, but let's just see what we have here. There's 1, 2, 3, 4, 5 lengths that they're referring to. We've got PE, but it's PE squared, so there's probably another PE. We have BE, we have BA, and we have BD. So where did PB and the other PE come from? Well, really BP. Okay, before jumping to the conclusion that they used another triangle, let's actually just see though. Okay, do we see a triangle with PE and then BP? Okay, that could be similar to one of these triangles. PE and BP. PE and BP. Well, the only other triangle that would go with that, right, would be this triangle. Okay, this blue triangle over this little triangle over here. So if we highlighted that, this is the triangle I'm referring to. That's the only one, because you see that if this is the center of the circle, then BP is a radius and then PA is also a radius. So they could have used that triangle as well. Okay, let's just roughly check because I can't just ignore things. I honestly feel like it's actually using these two triangles twice and it's using PE twice, but I still can't just ignore this. So let me see. If we were saying these two triangles are similar, which we can see they are, you see they both have a right angle triangle. They are both created using this hypotenuse, EB. So we can see that first, they are definitely similar because they're congruent. Here's why I say they're congruent. You see how they have 90 degrees and then 90 degrees? They're sharing this side PE, and AP is a radius and BP is also a radius. So that's side angle side. So they're congruent. Naturally, their angles will also be equal. Okay, congruency just means that the triangles are exactly the same in the lengths of their sides and their angles. Okay, so naturally, if two triangles are congruent, they're automatically similar as well. Okay, so these two triangles are similar. Let's just put them down quick. So if we have B, P, E, this triangle, and triangle A, P, E. Yeah, I don't think this is a good idea because no matter how I name these triangles, trying to include PE, seeing that it's one of the missing sides here, and then we have BP, I see that if I had to do that, let's try this, right? If I said BP over, I have to take it over AP because I took the first and second, so first and second here. And then it's equal to, you see how this just ends up giving you PE over PE? That's a problem. I can't really work with that. Yeah, PE is on the denominator, but now it's in the numerator. And how will we actually get rid of that eventually? Okay, so here it is. So even if eventually we found a way to work with these two equations, there's still going to be a problem because of that PE. Even if I did it in a way where I tried to make P the subject here and then P the subject here, I can still see how that will be a problem because in the equations, it will include dA and there will still be only one PE. So it's clearly not that triangle. Let's not work with that. Okay, I'm going to just go with this. So I'm going to ignore that and let's just go with this that we were referring to at first. Okay, I think they used two triangles here. Okay, they just used the proportions twice. So we can take it like this. And then let's also just see if we included the third sides in these triangles. So we took the first and third, second and, okay, so first and second. So that would be BP over BD. Okay, so over BD. And let's see how that would work. Now, before just working on it, I'm going to compare it to what we have here and just see the sides that we have available. So we have BE, great, okay. We have PE, we have two PEs really. We can find two PEs, okay, because I'm just putting them all together. But then we also have BA. So we've got, let me just mark it here. We've got BE, we've got BA, we've got BD, and we have BP. And then, of course, we have PE, which we can use twice because we can just use this, okay, ratio twice. So the only thing that would be, out of place is dA. But that will not be a problem if we use this twice. So here's what I mean by using it twice. You see, this is not a proper equation. You're saying something is equal to another thing, which is equal to another thing. Okay, that's not how equations work. Equations, it's one thing is equal to another thing. So here is how we can form these two equations. We can take BE, right, this one with BE, with this equation, with this ratio with PE. So we can take this as BE over BA and say this is equal to PE over DA. And then our second, and of course we'll have to put a reason here. So I will say similar triangles. You can name the triangles if you want to. Then the second equation that we're going to get, we can pair these two together. That way, PE is represented twice, and then we have dA, which we can just make the subject of each equation. Okay, so here's the thing. We can also just say this is BP over BD is equal to, and then we have again PE over dA. Okay, so two equations, again, because of similar triangles. So this part you can put in pencil. You can also leave it there. It's not a problem. There's nothing wrong with leaving it there, but this is what we're working with. And now with these two equations that we have, I'm just going to cross multiply. And my goal is to make dA the subject because I see that dA is not even included here. So if I can make dA the subject, eventually I can say dA is equal to dA. And because everything else is included, it should work out. So, okay, let's go ahead and do that. So this is BE multiplied by dA. Okay, so it's times dA and then is equal to, and then that is BA multiplied by PE. I can see how this is not going to work out, to be honest, because the problem is PE is in the numerator in both equations. Okay, I'm just going to continue. Let's see. So, and the other equation that we have is BP multiplied by dA. I'm going to make dA the subject in both. Is equal to, and we have BD, so we're cross multiplying. Okay, multiplied by PE. And then in both equations, dA can simply just be made the subject. So to leave dA alone, you're going to rewrite this as BA times PE over BE. And then this one would simplify to dA equals BD times PE over BP. And then naturally, because dA and dA are the same thing, we could equate them. And you see, this is why I'm saying I don't think this is going to work out. So BA times PE and then over BE is equal to, so you have to tell them DA equals DA first, and then we're equating them. So this is equal to BD multiplied by PE over BP. And then the whole point of this will be to make BE the subject, because that's what we had. We had BE is equal to, and then everything else there. Okay, so if you did that, two ways you can do it. You can decide to do it the long way, cross multiplying, which I think I should just show the step-by-step method. So let's say we had BE multiplied by BD, right? So we're cross multiplying and then multiply by PE. I would say it's equal to, and then I will multiply like this and be BP multiplied by BA multiplied by PE. And then we could just make BE the subject. So if you make that the subject, then the equation we end up with is BE equals BP times BA times PE over BD times PE. See how this doesn't work out? And the reason I've spotted that it's not going to work out already from here, because PE is in the numerator. We also tried using this triangle here, the only one that seems similar to that, and it doesn't work out. And I don't even want to try using this. I don't even want to try and find out, because now it's just going to include new sides that we don't even need. Okay, like AE and DE. So with this one, I am not sure, because it was working out well when we plan it out and we see the triangles that they're clearly using. All these sides are there. They really are there, but they may be something wrong. So what I'm going to do is, this is a 2022 paper. So let me go ahead and check the memo and see what they did there. Okay, I found the problem. Okay, so here's the problem. The method is fine, and it's even the same method they used. I couldn't really find any other method. Like, couldn't see any other triangle that was involved. It was those two triangles. But here's the problem. You see how they follow this as well? They also say, yes, BP over BD. They take the lengths of these that we have, okay? Like we did, we compared all the lengths. But the problem was, they spotted DA, that was good. And then they made DA the subject in one equation and in the second equation. The problem was this first equation. In this first equation, let's look at it from here, okay? Because up until here, this is still true. If you say BP over BD, it is equal to PE over DA, then that is correct. But then once you decide to make DA the subject here, you see how this equation is not going to make any sense now. If you had to cross multiply, you get BP times DA is equal to BD times PE. And then if you make DA the subject, you see that for this to be left alone, you have to divide both hand sides of the equation by BP, and that's all. And so this equation should have been BD times PE over BP. And then that would have been the equation of DA, because they follow the same steps here. They said PE over DA equals BE over BA. And then you see how they make DA the subject by leaving DA. So it's kind of like taking DA to this side. And so you see that BE has to go there. So what stays here on top would be PE, correct? What goes on the bottom is BE. And what will go to the top, because we're bringing this over to this side and we're making it a subject, we moved BE to the side, so it went to the denominator. So the only thing that would come up here would be this BA. Okay, you could also cross multiply, make DA the subject. It would be BA that you have here. So you see how they follow that? That's perfect. But because they didn't follow it here, then, So that's where it seems like the error came. So there is an error in equation 1. Because you see, for you to be able to say this is kind of like saying x is equal to a over b, right? On one hand, I said x is equal to a over b, like dA equals this over this. And then all of a sudden, I decide to swap the numerator and denominator and say x is equal to b over a. That doesn't make sense, okay? Okay, just like 2 over 1 is not the same thing as 1 over 2. So that was where the error came in. And so that's why it was so complicated to actually get to the answer, because the answer had an error in it. Okay, so you guys can still use it to study. Had those two equations worked out, then yes, we would have gotten that. So the only thing that it would actually simplify to would be, PE and PE would cancel because they're exactly the same. So at the end of the day, BE would simply just be equal to BP times BA over BD. And that would be the equation for BE. Okay, so that was the last question. And this is worth 12 marks, question 8. And that is it for question 8.